Let's do some long division of polynomial functions. So to get going on this, we have 5x squared plus 3x to the first power minus 2 divided by x plus 1. We're going to work through long division first and then try synthetic division after. So as we look at our polynomials, you'll notice we go nice x to the second, x to the first, and then a constant term. So we have that nice stair stepping down. We didn't skip any powers of x. And the same thing goes for our divisor here, x to the first power and then a constant. So again, didn't skip any powers of x. So if we had skipped any powers in either the dividend, the 5x squared, that one, or the x plus 1, we would include zeros as placeholders. So let's set this up. 5x squared plus 3x minus 2 is going to be divided by x plus 1. So to get started, what we want to do is always focus on this very first term and say to ourselves, x multiplied by whatever we're going to put in the quotient has to give us exactly our first term down here. So just focus on those first terms and say x multiplied by what makes exactly 5x squared. All right, so thinking through, I think we have x times 5x is going to make 5x squared, which is going to go underneath there. And what we're doing here is we're multiplying, we're distributing this 5x gets multiplied by the x. It also needs to be multiplied by that 1, the other term out there in our divisor. So 5x times positive 1 makes positive 5x. And you'll notice how this lines up nicely, that we have these good columns going on, that our x squareds get lined up, the x to the first powers get lined up. So what we want to do next as we do long division is subtract down. But we have to subtract all of this. Now we've lined it up, so 5x squared minus 5x squared is going to make 0x squareds out here. But we also have to be careful about the 3x, and writing this off to the side a lot of times really helps out students. You have 3x, and then it's going to be minus that 5x from the inside. Seeing it horizontally just makes more sense a lot of times. All right, so remember that negative gets distributed basically. So we have 3x minus 5x makes negative 2x, goes down here. I'm going to go ahead and get rid of our 0x squareds because don't really need that. I'll bring down this next term, minus 2, and we'll start our process again. Okay, remember our process is focus on the very first terms. So we're going to focus on the x out in front in the divisor, and then this minus 2x, and say to ourselves, x times whatever we put in the quotient has to make negative 2x. So x times negative 2, as we again take this negative 2 and distribute it to each of these terms out in front, it's going to make negative 2 times x is negative 2x. And negative 2 times positive 1 is negative 2. And then we subtract down again. So we have negative 2x minus a negative 2x makes 0x's, which doesn't really add too much to this, so we can get rid of the 0x's. And remember, we've planned it out so that first term should go away every single time. The follow-up on this is we had negative 2 minus a negative 2 for our constants, which is going to be negative 2 plus 2, which is going to end us up with 0 for our remainder. Let's go ahead and identify our pieces here. We have a remainder of 0, and then what's up above here, this is referred to as the quotient. Now, if our remainder hadn't been 0, we could take the quotient plus the remainder divided by the divisor. But in this case, because the remainder of 0, that doesn't really add much. All right, next, let's try this with synthetic division. So to set up synthetic division, what we do is we focus on the coefficients on each one of these terms. We're going to go ahead and list those off up above. So 5, positive 3, negative 2. And again, we didn't skip any powers of x, or we would need to include zeros as placeholders. Next, what we do is we think to ourselves, all right, we're dividing by x plus 1. So what value of x would fill in here to make this equal 0? So negative 1 plus 1 would equal 0. The other thing to take note of here is we can do synthetic division on this one because it's a very specific divisor. All right, this divisor is 1x to the first power. If we had an x squared out there, I would not suggest using synthetic division. If that was 3x plus 1, I would not suggest using synthetic division. I would just use long division in those cases also. All right, but in this case, we said -1 plus 1 would make 0. So I'm going to put a -1 out in front. Next, I'm going to leave a row blank for now and draw a nice horizontal line. To get going, we always bring down this very first term, or the first digit here. We have the 5. And now our process goes add. Nope, it does not. It starts out with multiply and then add. All right, so we always multiply by our term out in front. All right, the -1 gets multiplied by the digit at the bottom. So we do -1 times 5 makes -5. That's going to go in this next row. Now we add. So we're adding vertically. So we have 3 plus a -5 makes -2. Now we're back to the multiply. So remember, you're going to multiply that -1 out in front by the -2. -1 times -2 makes +2. Now we're back to add. Add vertically. So -2 plus 2 makes 0. Now how do we read this? All right, that's the next important part. This last part here, the 0, is our remainder. And then our quotient is given by these other values at the bottom. It goes, the first one here next to the remainder is a number, a constant. And then this next one gets an x with it. All right, if we had additional values, we kind of count up and it would be an x squared for the next one and so on. So our quotient is going to be 5x minus 2. So notice we get the exact same quotient, the exact same remainder in both of these, but you do have to be a little bit careful when you can use synthetic division when you are dividing by 1x to the first power, either plus a number or minus a number. So I hope this helps out as you're working on dividing polynomials. Good luck.